Old footage time. I took my Vyvanse. I finally got a prescription for it. So, we're doing the Hunsdiecker Cristol-Firth modification of the Hunsdiecker reaction, whatever. But the Hunsdiecker decarboxylation reaction is basically when you have an aromatic, I don't think it has to be aromatic, but you just have a carboxylic acid, and it removes the carboxyl group while replacing it with a halogen, most typically bromine, because it's convenient. Chlorine, I guess you could use chlorine, but it's a gas, and iodine, I guess, but I don't know why you would do that. Either way, so I thought this reaction was interesting. It hasn't been featured on YouTube before, not even the silver one. But this modification is supposed to make it a lot more consistent, better yielding, and less water sensitive. In fact, the reaction forms water as a product. So I probably did not have to go and flame dry all my glassware. Then again, I don't know. I don't know how sensitive this is to moisture. But I ran it under, you know, flame dried glassware, dried under nitrogen atmosphere and all that stuff. But I'll put the DOI, you know, literature in the description or a comment or something. If I forget, yell at me, but you could probably find it by just looking up this name. But that's what they did. Again, the original reaction uses silver salts. Silver sensitive to light, reaction sensitive to water. It's very finicky when you use silver. This uses mercury. I think lead or barium, not barium, cadmium, I don't know. But some other metal salts also work. I have not been looking into this a lot. I don't know the reaction mechanism either, because this is months ago. This is old footage I'm trying to get off my phone because it's taking up storage space. Not enough place for me to store furry memes. So that's blah blah blah, whatever. In opposite to the silver reaction, this one you actually need light. It's photocatalytic. I believe one of the intermediates is an organohypohalite, so you want to decompose that with light. I'm not sure. I forgot. But yeah, so I doubled the scale. These are the amounts I'm using. These are the actual amounts I weighed out and whatnot. But you know, enough of me blabbering at the start here. Oh, one more thing. The yield I got, it was like a few drops of an orangey viscous liquid that was partially crystallizing. So I don't know what I made. It smelled like bromochlorobenzene I had bought from a commercial source. So I'm inclined to think I at least got some kind of halobenzene out of it. Now, is it the 2-bromochlorobenzene I'm trying to make? I don't know. It could just be chlorobenzene if the bromination did not take place. I don't know. But it smelled similar. So there's that. Now, the amount I got, I could not possibly distill it or even check boiling point. I tried to. And TLC on such a simple compound, you know, with a bromine on there instead, that's just not very qualitative or anything. It's just not useful as a measure. So yeah, I don't have analysis equipment either yet, so I don't know. I don't know what I made. I think it worked, but the yield is still abysmal. Well, it wasn't too bad, I guess. It was, you know, 9/10 of a gram. That's fine, I get. Well, it's crude after root of whatever. It's decent. But yeah, let's go ahead and actually look at the video now. So the round bottom flask was flame dried, even though it probably didn't have to be. And into here we will add 6.497 grams of red mercuric oxide. Theory says 6.498, and this will form our metal salt. And then I added 3.139 grams of 2-chlorobenzoic acid. Theory says 3.1314 grams, and this is a bit brown, presumably because of copper oxide, because this was prepared from a Sandmeyer reaction, and I think some copper ended up crystallizing out with the actual acid. I'm not sure. I did recrystallize it and do an acid base on it, or base acid on it, but I'm not sure how well that actually purified it. It grew nice crystals at least, so presumably it's some semblance of purity. But if there is copper in here, that could be why the reaction got messed up. Maybe it was forming something strange in there with the mercury. I don't know. Also, stir bar to get this mixing, because this will be a heterogeneous mixture, so good stirring. And on 40 milliliters of a chloroform carbon tetrachloride mixture, because my chlorination didn't go to completion, I should have actually used something like 100 milliliters of carbon tetrachloride, but I did not. That could also be why this reaction failed. And then had to stir it by hand a little bit to get the mixture suspended so the stir bar actually works. Now, the red mercuric oxide is actually not really anything special. It's just mercury oxide. It's just particle size that makes it red. Again, I did not know how sensitive this was, so I ran it under nitrogen, probably unnecessary. There's bubbling rate, and I used a 30-watt tungsten lamp, I think, because I did not have a 100-watt lamp. Now I added the bromine in, and when it hits the refluxing reaction, it is well above the boiling point. So there definitely is a rush during the reflux addition, but I'm pretty sure most of it is just the bromine boiling. Now, unfortunately, that also means a lot of the bromine vapor was swept into my oil bubbler, into my lines, through the syringe, and needle, and rubber septa, so it damaged those a little bit. The rubber septum actually held up pretty well, so I'm happy that I bought the chem glass rubber septum as a replacement for the Chinese ones. Here you can see I got mad at the water in there during refluxing. I also later found out that my bromine was a bit wet, so it could be that too. I don't know. Again, this reaction makes water, so I don't know. But the moisture causes the mercuric oxide to all coagulate eventually. There you can see the bubbling from nitrogen, and if I remove the nitrogen line, it still continues to bubble. So that would presumably be carbon dioxide forming, indicating reaction progression. But because this is a heterogeneous reaction, it probably should have ran for way longer than I let it run, which is about 3 hours. But yeah, you can see here, there's a white solid, which is probably mercuric bromide. And yeah, I mean, again, reaction going forwards. And here you can see a lot more of that white solid accumulating. And it's been 3 hours or 4 hours or so. I lost the workup footage. But I added 60 milliliters of saturated sodium bicarbonate solution. I filtered it through cotton ball because I did not have sea light, and I washed the filter with a bunch of chloroform, and then I dried it over probably sodium or magnesium sulfate and stuck on the rotavap and rotavapped it down, and that's how I got the residue at the end. As for the mercury waste, everything that was contaminated with mercury was dumped into a big 2-liter beaker, and which had a little nitric acid added to it. I also rinsed out the flask with some dilute nitric acid to dissolve any more mercury. And into that solution of mercury salts, I simply placed in a big piece of copper. So into this, we'll just put some copper scrap. And that dropped out the mercury as metallic mercury after the nitric acid was consumed. And I just put that mercury into a mercury metal jar, which I'll just recycle at some point because mercury is costly. Yeah, I mean, not too eventful, I guess. And during this time, I was working a lot more with mercury stuff because mercury chemistry is interesting. It has a lot of uses in organic chemistry, surprisingly. So I had my blood tested for mercury, and it came out fine, so I'm not particularly worried about that. I'm clearly not mercury poisoned right now, so, yeah. But yeah, I did not calculate yield, but I don't think it's good, so I'm not going to. We'll continue with the footage. So we have about 0.9 grams of residue, which is not a very good yield, obviously. I was expecting 3.84, but it does seem to be the right thing because it smells like chlorobenzene. But yeah, we really did not get anything out of it. I tried to TLC it. Like I said, you just really can't TLC these things. I thought maybe, it'd show me some other impurity. I believe this is the reference sample of the commercial product, not actually the one I made. I think I discarded that one in the halogenated waste a long time ago. But yeah, I have a sample that I bought because I wanted to see if the synthesis was viable. And yeah, there's just, I don't know of any way I could compare the, and analyze it for purity and identity confirmation. Aside from maybe elemental analysis, but again, I don't have that instrumentation in here. So, yeah, I mean, this video is a nothing burger, but I hope it was... Oh, I see it. I, in fact, did not discard it in the halogenated waste. There it is. You can see what I meant about it crystallizing and not looking particularly good. I think, yeah, I added DCM to this, so that's why it's a lot more volume. But you can see there's some kind of solid precipitation, so... that's definitely not product. There's also a biphasic mixture in here now, so I don't know what's going on with it. But yeah, it smells like mothballs. But most halogenated benzenes do, so it's not indicative that this is 2-bromochloro. It's just indicative that it has a halogen on it somewhere. Or maybe even multiple, I don't know. But yeah, this video has been nothing but it's lab notes, so if you want to run this reaction yourself or something, go ahead. I'm not gonna, well, blah blah blah, safety, mercury's poisonous, carbon tetrachloride is a liver damaging thing, also kidney damaging, I think, also carcinogenic, also pretty toxic on its own, blah 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 blah. You get my point. This is for demonstrational, educational purposes, but yeah, it did not work very well. Maybe I'll retry it someday else, I don't know.